Okay, I'm going to take a chance that this is operating correctly and that you guys could actually see the paper that I have here. This paper is a very simple block kind of diagram for the schematic and the wiring that's going on with my shock-free energy. Right here we have the hot line in, 120 volt line in, and this is my spark-free energy device. It has 0 volts. It draws 0 volts and has 0 current draw. What I'm endeavoring to do here with this video is explain to you what's happening when we short the line from the hot line to the neutral line. What's happening is that this device here, the heat dissipating device, is stopping any current from going back through the line. Now, when we short it, what's going on is that the total power is going back through the PG&E line. So let's say if we're shorting from right here to here, and the PG&E line is coming in, all the power is going right back out through PG&E line, and as you saw in the last video, the current actually dropped instead of rised in the actual line. Now, of course, if a short happens, it's generally not going to happen from here to here. It's going to happen across. It's going to happen across the load. And so what's going to happen is that this line, all the way to the point to where it sees PG&E, is going to see the heat, and hopefully the circuit breaker is going to trip. Now, I haven't seen any evidence of that. I haven't been able to trip a circuit breaker yet, and I'm not really trying to. And I believe the reason why it's not tripping is because there's no heat. The heat is just not there for the circuit breaker to work properly. There's a lot of current on this side of the line, and from where I'm at, this side of the line is going back to the panel, to the main panel. So there's other loads, obviously, and other lines, and the line that's actually going from my boat to back to the panel. That whole line is actually seeing the short from here to here. Okay. This current device here, what it does is it sees the heat coming from the load, and it actually absorbs it. It absorbs the heat through the magnetic draw of the current to this particular load. It is a load. It's a very small resistance load, and it does have a current draw and a voltage drop across it of approximately 1.8 to 2 volts. You'll see a current drawn through the load at 0.164 amps, or 164 milliamps, or 164 microamps. I'm sorry. No, I had it right. 164 milliamps. This device here is accepting all the heat from everything from here on, and well, most of it anyway. Most, if not all of it. And when we short it, what it does is it just creates a loop back to the line, and the only thing that we're going to have a problem with is either getting the circuit breakers to work properly, or to create lines that will not burn up the way they do now. One thing I can say for sure is that the line is not going to get hot immediately like it did before. When you had a direct short before, the line would get instantaneously hot and start to burn almost immediately. Now, I have to admit that I didn't hold the line in short position very long. I pulled it off. It was only there for a fraction of a second, or maybe a second at the very most. And when I retested the lines, and this is why I'm coming back here, because I retested these lines and found that when I short like that, I do get 20 amp current draw on this side. I'm sorry. I do get 20 amp current draw from immediate contact from this side and this side. So both sides on the neutral line and on the hot line do get a high amperage draw when we short for even a very quick amount of time. I read up to 26 amps, but even still, the line is not getting hot, and that's kind of perplexing to me. I think what's happening is since we neutralize the electrostatic charge, that a lot of the heat index has been taken out of the line. So with that, I'm going to call it a day with this one, and hopefully we have some more information that is useful to anybody who has a little more knowledge than I do about electrical circuits. I'm not an engineer by any stretch of the imagination. I do have an engineering license as for low voltage kind of stuff. I worked as a communications technician for satellite communications, kind of uplinks and downlinks and stuff like that, which required me to have knowledge of high voltage lines as well, because we did stuff with Europe and other places as well, where we had to convert the voltages and all that kind of thing. So that being said, I am not an electrician. I am a technician, an electronic technician, and that has a good working knowledge of high voltage systems. Therefore, I was able to do this because, to be quite honest with all of you, this was an accident. I'm working on free energy, and this is just another failure for my free energy concept. However, the fact that it is working in the capacity of drawing out the electrostatic charge tells me that I now have a working understanding of the magnetic field and how it operates, and from there, all things are possible, and I promise you, I will have free energy in the upcoming years. Within the next 5 years, I'm quite certain I will have free energy. So with that, folks, I will let it go and bid you all a good day, and thank you very much for viewing my video, and until next time, peace.